All right, what we're going to talk about today, we're going to talk about the idea of graphs of trig functions. Okay, that's the next progression in regards to what we did in trig class. We looked at trig ratios, found trig ratios, and then reference angles. Then we went into graphs of trig functions. That's what we get to talk about today. We have base equation for a trig equation. We had vertical phase shift plus or minus the amplitude, sine, cosine, b, x minus horizontal phase shift. That was our base equation that we went to each and every time, where A was equal to our amplitude. It's a distance from the prime axis to the peaks and valleys on the graph. And once again, as we go through this, hopefully you have some recall into what we did back in trig class. We had to deal with the amplitude. Amplitude was the distance from the prime axis to our peaks and our valleys. The period was the number of degrees from a point to on a graph to a point at which the graph starts to repeat the pattern. Once again, we have trigonometric functions are called periodic functions because they will repeat over and over and over again, just like a roller coaster. And if you remember back to our graphs of trig functions, they're pretty much roller coasters. So it's a number of degrees from a point to a point on the graph where the graph starts to repeat itself again. You start to repeat the pattern. How we calculated this? First off, our amplitude was our coefficient to our sine or cosine. The period was calculated by 2 pi divided by b, or we can write it either way. 2 pi divided by b as a fraction, 2 pi divided by b horizontally. We also had when we were in a degree mode, we had 360 divided by b. If you're do a little bit of recall, 360 divided by b. The vertical phase shift is the vertical phase shift of a horizontal axis of the graph that the graph will oscillate about. We called this the prime axis when we talked about the vertical phase shift. When we had the vertical phase shift, that was our prime axis. If we take a look, here's our vertical phase shift right here, the VPS. Then the horizontal phase shift. The horizontal phase shift is a horizontal shift of the graph. The horizontal shift of the graph it is also our degree start value. So when we deal with the horizontal phase shift, is basically where our graph starts. Where do we start our graph? Where do we start the graph? What degree measure do we start our graph? And everything we're going to be dealing with here is we're going to be dealing with everything in radians. Okay, we will not be dealing with anything in degrees here. For a sine curve, remember on the sine curve, Once again, we started on the prime axis. The graph started on its prime axis for a sine curve. We started on the prime axis. And for a cosine curve, we started at a peak and a valley. Peak or a valley. So we start at the very top of the hill or the very bottom of the hill. So we want to find all of our pertinent information we want to graph. We want to graph. We have y equals 2 plus 3 sine pi over 3 x minus 2. So we have the amplitude, period, vertical, horizontal phase shift. The amplitude is the coefficient to the trig function. So Mickey, what's our amplitude? 3. That is correct. Here's my coefficient of the trig function, so I have a value of 3. The period is calculated by 360 or 2 pi divided by b. Our b value, we take a look at our equation. What is the b value, Noah? Where's the b value? The b value, here's our b value here. Where do you see a 120 up here?
I did 360 divided by 3. Pi equal 180.
What's our b value up here? What's the b value?
Pi divided by 3.
Pi divided by 3. Okay, let's keep this simple. So we have 2 pi divided by pi over 3. Now, if we are multiplying or dividing fractions, dividing by a fraction, we have to flip and multiply by its reciprocal. So we have 2 pi times 3 over pi. What happens to the 2 pi's, Isaac? They cancel out. So this pi cancels this pi, so we're left to 2 times 3, which is 6. Vertical phase shift. Vertical phase shift. Looking at our equation, what's our vertical phase shift, Brooke? 2. Horizontal phase shift. What's our horizontal, L? What's being subtracted from x? Just 2. So that would also be 2. We take a look. This is x minus our horizontal phase shift. So we ask ourselves, what's being subtracted from x? And that is the value of 2. So let's take a look at a graph. I'm going to make this a little top heavy here. Okay, if you remember, when we were looking at our vertical phase shift, that sort of helps us tell us what our graph's going to be. Okay, do I make it a little bit top heavy or bottom heavy? First thing we draw in there is the vertical phase shift. Your prime axis. So we draw in our vertical phase shift at a value of 2. All right, second thing we take a look at is we take a look at the horizontal phase shift and our trig function. Okay, the horizontal phase shift and our trig function. The horizontal phase shift will tell us our degree start value. Where do we start our function, our graph at? The trig function will tell us, do we start on the prime axis or do we start at peaks and valleys? Well, we have a sine curve, so it tells us to start on the prime axis. So at our horizontal phase shift, that tells me my degree start value, which is a value of 2. My trig function tells me to start on the prime axis. So at 2, I'm up on my prime axis. Third thing we take a look at, it's a period. It's the number of degrees till the pattern starts to repeat itself again. So if I'm at a value of 2, the period is 6. That means every 6 units, my graph is going to repeat itself again. So if I start at 2, Preston, at what x value will the graph start to repeat itself again? 8. So if I go out to 8, I will be on the prime axis. Now we start playing the games of halves. They are games of halves. Halfway between 2 and 8. What's the halfway point between 2 and 8, Mickey?
5.
The value of 5. 2 plus 8 is 10 divided by 2. I get a value of 5. Do you remember where we're at? On the prime axis again. Our games of halves between 2 and 5. Halfway point, add them together, divided by 2. That's 7 divided by 2, 3.5. Kirsten, where are we at? Do you remember where we're at with our y value? At 5. We would be up at 5. Because we go to our peak. Then we play one more games of halves between 5 and 8. 13 divided by 2, 6.5. Remember where we're at with this one. Where would we be at? Angelique, do you remember? Okay. Our amplitude tells us how far we go up and also how far we go down. -1. So it's 6.5, we're at -1. So if I look at my sine curve, once again, we get a roller coaster ride here. If we look at sine, once again, I guess I should have put something here. We're going to have a roller coaster ride. Cosine, we start at a peak, and then back up again. So if I draw on my prime axis, our cosine will look like a U. Our sine will look like a roller coaster. Once again, the hope is as I started hitting my Q's in regards to my graphs, there's some recall that you have in regards to how we graphed our functions. Graphing the reciprocal functions. Okay, for secant, we use cosine. For cosecant, we use sine as our guide functions. We just look at the reciprocal functions to utilize for our guide functions. So for secant, we use cosine because they're reciprocals to each other. And for sine or cosecant, we use the sine because they're reciprocals to each other. Okay, where the graphs of the sines and cosines hit the prime axis, we had asymptotes, vertical asymptotes. We have vertical asymptotes are formed where we cross our prime axis. And for secant and cosecant, those were our parabolas, our asymptotic parabolas. So you're going to get asymptotic parabolas. So let's look at the secant of pi over 3, x plus 1. Okay, if we're dealing with a secant here, if we're dealing with a secant, we want to use our cosine function as our guide. Find your amplitude, period, vertical, horizontal phase shift. Jordan, what out for the amplitude and period? 4 for the period? What's our B value? Pi over 3. When we had pi over 3 up here, 6. once as you go through these, you'll learn it's if you have a fraction pi over something, it's always going to be twice the denominator. It's going to be double the denominator. So if you have pi over 5, it will be 10. If you have pi over 4, it's going to be 8. If you have pi over 2, it's going to be 4. If you have pi over 7, it's going to be 14. Vertical horizontal phase shift. What we have with the vertical and horizontal phase shift? Riley. What's being subtracted from x? -1. So we have an x minus a -1. We got a little ching boom here. We have x minus a -1 to give us x plus 1. So let's get a graph down of our cosine. First thing to take a look at, vertical phase shift, drawing your prime axis. Second thing we take a look at is our horizontal phase shift to where our start value is. Then we take a look at the trig function, which is cosine. So if we have a cosine, we have to start at a peak or a valley. So what we're going to have to take a look at is also the amplitude here, because that tells us what is our distance from our prime axis to our peak, our prime axis to our valley. So at -1, we have a cosine curve. We have an amplitude of 3. At -1, what would be our y value here, Tess? 5? Next thing we take a look is the period. Tells us if I go that distance, I'll be at the exact same spot of my graph again. So if I start at -1, the period is 6, Dad, where are we going to be at this value of 5 again? At 5. Now we play our games of halves. Halfway between -1 and 5. Olivia would be where? At 2. Okay, and that's going to be at a valley now. So where would be at, what would be our y value at 2? Then we play our games of halves 2 more times. and that's where we're going to cross our prime axis. So we cross our prime axis where, Abby? What two values? If I complete my cosine curve, okay, wherever we cross the prime axis, we will have vertical asymptotes. And with your secant and cosecant curves, these are, I call them asymptotic. Parabolas. From your peaks and your valleys. So it would be asymptotic parabolas from your peaks and your valleys. So if I take a look at my one in between here, here's my asymptotic parabola. And what we could do with the cosine here, we can either do one of two things. If you remember, we could do two half ones. Or if we wanted to, I have a peak, or I have an asymptote at 0.5, then 3.5. We could throw in another asymptote out there at 6.5. Either way is a correct way of doing it. And then I could complete my parabola out there. I have to have symmetry, so I should have equal spacing between my asymptotes. Now I'm going to get to the tangent and cotangent ones on the back. We will do them tomorrow. But what you'll be able to do for today is the ones on here that are sine and cosine and secant and cosecant. Once again, we'll deal with tangent and cotangent tomorrow. So problems 1 and 2 you'll be able to do, and problems 4 and 5 you'll be able to do.